I want to talk to you about kind of a difficult topic that take a while to understand. So this is something to really slow down on, and it's a bunch until you get really good at it. A lot of skills you've already learned about atomics, about chemical reactions, double displacement, double replacement, or single replacement. These things you've already learned. Now we have to put them all together into one thing, so it takes us a while to get used to it. An example of that is when limestone caverns formed, and carbon dioxide and water combine together and they form this carbonate and stuff inside of caves, stalactites and stalagmites. So this is a chemical reaction, precipitate reaction. This is making a solid precipitate to make this in the cave, and net ionic equations, which are the hard for used to. So let's talk about it. So we're going to show a net ionic equation, and we're just going to talk about what ions form together to form the solid. We don't care about everything else that's in the reaction in the beaker that's present there. We just care about the ions that are forming into a product. So that's all we care about in a net ionic. There's going to be a lot of ions just hanging out, looking, watching. They're called spectators. Just like when you go to sports and you sit in the stands, you're a spectator. Same thing in a beaker. You have ions in there that do not react, and they're watching the show. And then we have the ions that are actually working together to form a precipitate, a solid. Okay. So here we're seeing an example of something called a complete ionic equation. We have taken silver nitrate, thrown it into water in a beaker, and it broke into two pieces. We took salt as a solid, we threw it in water, and it turned into two pieces. And then this is the reactant side beginning, and the after picture shows that we've made the solid. So when we put these things in a beaker, they all sit there, but only these two actually react. It's the silver and the chlorine. Chlorine makes silver chloride, and it makes this white milky looking stuff. If you let this settle and take off the water part, it's going to be a solid down here. So we're making a solid. These guys are just sitting around watching the show. So these, a sodium ion, nitrate ion, are spectators. So this is called the complete ionic equation. It's showing everything that's sitting in that beaker. And then we're going to get rid of the spectators, and we'll call that the net ionic equation. So right here you're seeing the complete ionic equation. On both sides we have elements that are just sitting there watching, ions that are just sitting there. They're called spectators. And the net ionic equation shows the reaction solution that shows only those particles that are really involved in the chemical change, just the ones making the solid. So we have to be able to go from complete to net ionic equation. We need that skill. So we only care about the things that are forming the solid, and we have to balance everything. So right here is showing this is the net ionic of what we were just talking about, of the silver and the chlorine coming together to make silver chloride solid. So this is called the net ionic equation. This one here is the complete ionic, so showing everything in the beaker. This one is just showing the ones that are making the silver chloride. So we have to be able to write both. You have to get good at that. So here's an example. We have iron 3 chloride in water and potassium hydroxide. They're mixed together and they form a precipitate. They make this is your product solid right there that you're seeing, this orange stuff. That's the precipitate. So we're going to write out everything we threw in the beaker. We put iron chloride in there, we put potassium hydroxide in there, and then the iron hooked up with the hydroxide formed the solid. Here's a spectator, here's a spectator. So this is balanced as the complete ionic. And then we get rid of all the spectators, and now we have the net ionic equation. Very important. It's going to be a skill you need to work at because it doesn't come easy for most folks in class. So I need you to practice this. So see if you can do this one. This is the complete ionic right there. See if you can pause this and do the net ionic equation. How can you predict what's going to be the solid if you're not told what the solid is in a double replacement reaction? So there's rules for that, and they're called solubility rules. So here's the rules. If you have anything that wants to hook up with this alkali metal, that's group 1, and ammonia, anything that has a alkali metal or ammonia in it, it's going to be soluble, not going to make a solid, not going to make a precipitate. These guys, if they have these two in there, it's always going to be soluble, never going to make a precipitate. If it has these sulfate salts except hooked up with these guys, it's going to be soluble. That's got chloride in it, but it's hooked to they're going to be soluble if it's got chloride, but unless it's hooked to these guys. If chloride's hooked to these guys, you're going to have a solid. Okay, most carbonates, phosphates, chromates, sulfides, hydroxides hooked to somebody else are insoluble. These are the ones that are going to make your solids. Okay, solids here, solids with these guys. So solids with these guys. So these are the ones we're going to look for to get our precipitate. So we've got sodium in a beaker, we threw some carbonate, we threw some barium, and we threw some nitrate. So what's going to hook up together to make a precipitate? So you look at the rules, and you try to figure out who would make a solid from the insoluble ones. Insoluble means it makes a solid. So if we looked at the carbonates, remember carbonates like to make solids, so we are going to have the barium and the carbonate coming together to make the solid. So double replacement, and it formed a solid. So let's try our quiz. So I need you to practice these, and this will take us a while to get used to. So figure out the correct net ionic from the reaction and spectator ion if there is one. So look at these. This is the overall beginning, ending, and see if you can figure out what the net ionic would be. So pause me, quit my yapping, stop me talking for a sec. Let's see if you can figure it out, and then I'll show you the answer. Okay, here is the answer. We've got this liquid forming. That is going to be your product. And anytime you see liquid or solid, this is going to be what we care about as our net ionic. So liquid was the thing we cared about. And we had to have this oxygen and this hydrogen to make that water. Okay. Spectator just hanging out was the chlorate. Okay, next one. Which would not form a precipitate? So this is your solubility rule. So pause, look back at the solubility rules, and then I'll tell you the answer. So this one, molybdenum nitrate, would not form a precipitate because nitrates are soluble. That's from that rules that we have back there. Which will not make a precipitate. And we use PPT or solid as the abbreviation for precipitate. So pause me, try to figure that out. And so this would not make a precipitate because anything with sodium is soluble, anything with sulfate is soluble. So that's why. Alright, I'll talk to you soon. We need to practice this. So work on this till it feels more comfortable. There's a bunch in the book to try out. And I'll talk to you soon. Have a great day.